Hello students, my name is Prashant and I have started 7th standard mathematics, that is chapter 1 integers. In previous session we learnt about the properties of integers. Okay, I explained in properties of integers we will discuss 4 properties. Among those 4 properties I discussed closure property yesterday only. Okay, closure property. What are the 4 properties? Closure property, commutative property, associative property and distributive property. Okay, these properties I decided when integers are gone through different operations. What are the 4 operations? Addition, subtraction, multiplication and division are the 4 operations. Okay. Yesterday I covered first property, that is closure property of integer, and what was our conclusion on that property? Integers are closed under addition, subtraction and multiplication, whereas integers are not closed under division. Okay, this is our conclusion yesterday. Today we are going to discuss about the second property of integer, that is the commutative property of integers. Commutative property. Commutative property of integers. In this commutative property of integers, again depending upon in which operation. Okay, for example I discussed about 4 operation. Again we divide it into 4 types. Okay, before going to that, what do you mean by commutative property? First we will see what do you mean by commutative property. In mathematics, in math, or you can say, or in mathematics, any operation means what here? Addition, subtraction, multiplication and division. Any operation is known as commutative. In mathematics, any operation is commutative if there is a condition. To call any operation as a commutative, there is a condition. If the operands are exchanged, then result must be same. Result must be same. Okay. After writing this statement, there may be many questions in your mind. Suppose what in operations is clear yesterday only. What do you mean by operation? Now one more new word came here, that is operands. Okay, operands means the number which are involved. For example, 5 plus 3. Which operation is here? This addition. Which numbers are involved in addition? 5 and 3. These two numbers are known as operands. Okay, maybe any number. 5 plus 3 plus 8 minus 4. These are all 4 numbers. 5, 3, 8 minus 4. These all are known as operands. The numbers which are involved in that operation. Okay, and what you are doing is known as an operation. So operands. So what says the statement? Says this is the statement of a commutative property. In general, what do you mean by commutative? In mathematics, any operation is commutative if the operands are exchanged, then result must be same. Suppose a plus b. Okay, a plus b. Operation is addition here. Operands are a and b. Then if you exchange the operands, in place of b, if you take a, sorry, in place of A if you take B, in place of B if you take A, operands are exchanged. Exchange no, here A, B, here B and A, and you have to keep the operation same as it is, then result must not change. Okay, means you should get the same result, you should get the same result, then it is known as commutative in nature. Okay, so this is the general explanation of a commutative property. Now we are looking at a commutative property of integers. We checked commutative property of natural numbers and whole numbers in previous year only. Okay, so the natural numbers are commutative in nature, especially, and whole numbers are also commutative in nature. Now today we are going to see whether integers are also commutative in nature or not. Okay, again in the you can note down this much. Okay, you can note A plus B, B plus A, this place. Okay, you can note down, you can take down the screenshot of this much, you can write it in a new page, that is commutative property of integers. Okay. Now in commutative property, depending upon the operation, the result will change. Okay. Today I will not go into too much depth because yesterday only I discussed too much about these properties. Today in short I will try to finish this commutative property. In commutative property of integer, operation by operation, first operation we will look at addition. See whether integers are commutative under addition or not. Okay. Whether integers are commutative under addition or not, we have to check here. Then we have to take two numbers or more than two. For the sake of this understanding this concept, we will take only two numbers. Suppose let us say take any number A and B. First we will try with the positive numbers. Okay, we will try with the positive number, plus 10 plus 15. Addition operation. If A plus B is equals to B plus A, if A plus B is equals to B plus A, means see here I am exchanging the operands. B is coming at a place of A is moving at a place of B, means I am exchanging the operands and I am keeping the operation same. Even though by substituting these values in both two expressions, if I get the same answer, then what is my conclusion? What will be my conclusion? Integers are commutative under addition. If our answer does not matches, if LHS answer does not matches with RHS, then we can say integers are not commutative under addition. Okay, we will try. First we will try with the two positive numbers. Put A equal to A is how much? Plus 10. In place of A, plus 10. This plus as it is. In place of B, plus 15. Solve it. Plus into plus, plus 10 outside. Plus into plus, plus 15 is outside. Both are positive. What you will do? We are going to add them? No. We are going to add both numbers. 10 plus 15, 25. Greater number sign, plus 25. Now you check here. In place of B, write B value is how much? Plus 15. This plus as it is. In place of A, plus 10. Solve it. Plus 15, plus into plus, plus into plus, plus 10 is outside. Both are positive. Add them. 25 is your answer. 3 terms. Both are equal, no? Both are equal, no? Therefore, this is our first example. Okay, in this case I got LHS equal to RHS, means in this case what happened? A plus B is equals to B plus A. What happens if I take two negative numbers? What happens if I take two negative numbers? Whether result remains same or result will alter. Let's see. Okay. So this much you can take as a first example, no problem. Now you check that for A equal to minus 25, b equal to minus 15. Let's try. In place of a, minus 25, plus as it is, in place of b, minus 15. Solve it. Plus into minus, minus 25, plus into minus, minus 15. Both are negative. Both are negative. What you have to do? You have to add the numbers from 25 plus 15 is a 40. Greater number sign minus. Check here. In place of b, put minus 15. This plus as it is. In place of a, how much? Minus 25. Now plus into minus, minus, plus into minus, minus, both are negative. What you have to do? You have to add the number 15 plus 25, again it's 40. Greater numbers, again both are equal, means here in this case also, whether you take both, whether you take two positive integer, whether you take two negative integer, integers are commutative under addition. Integers are commutative under addition. So what is our conclusion? Therefore our conclusion is, if a b or a comma b, instead of writing belongs to, I can use one symbol. This, it's like a C and it's like a somewhat E, mixture of a C and E. It's like a mixture of a C and E. This symbol is known as belongs to. Instead of writing belongs to every time, we can use this symbol. If a b belongs to integer, is there any need to write integers every time? No, because we assigned one letter for it. What is that? Z. Z is a letter. It shows the set of integers. If a and b belongs to integer, okay, then a plus b is equals to b plus a. A plus b is equal to b plus a. If you want to write it in a words, how you can write? Integers are commutative under addition. Both are same only. Integers are commutative under addition. Sorry, it's not visible. I'll write it here. Okay, it is not visible in the screen. Yes, for you. Integers are these are commutative. These are commutative under addition. This is a mathematical form. This is in words, means we can write 15,000 in numbers also, 15,000 words also. Likewise, both the meaning of both these statements are same only. This is but this is in a this statement is in words. This statement is in mathematical form. That's it. Okay. Integers are commutative under addition. Now we will check whether integers are commutative under subtraction. Okay. In short, we will take one example. We will take one example because this the length of the video is going to be more. Okay. Second, commutative property of integers. In that second one is a subtraction. Subtraction. Okay. See, let us take two integers, any two integers of your choice. If you subtract them, and in next step if you change the operands, and if you subtract them again, if your answer is equal or same, then it is no, then integers are commutative under subtraction. If your answer differs, okay, then it is known as a commutative. Integers are not commutative under subtraction. Let us choose any two numbers. I choose plus 10 and plus 3. So I have to check a minus b and b minus a. I must get 2, these LHS and RHS same, then only I can say these are commutative. Okay, integers are commutative in under subtraction. Let us substitute. In place of a plus 10 minus, in place of b plus 3, plus into minus, plus into plus 10 outside, minus into plus minus 3 outside, plus 10 minus 3, subtraction, 10 minus 3 will give you 7 greater numbers. Okay, now solve here. In place of b plus 3 minus, in place of a plus 10, plus into plus 3, minus into plus minus 10. Again different signs, subtraction, 10 minus 3 will give you 7, but which sign you have to use? Greater number sign. Now check here, one is plus 7, another one is a minus 7. Are they same? Are they same? What do you think? Plus 7 and minus 7, are they same? No, of course they are not same, completely different. They are completely different. So LHS and RHS is not equal. Therefore a minus b is not equal to b minus a. Therefore what is our conclusion? What is our conclusion? Okay, our conclusion is, therefore integers are not commutative, under subtraction, okay. So I am solving one example. You can put different values of integers in place of a and b. You try it in your home. Okay. If you get same answer, please click the click one photo of that your solution and send it to me to my number. Okay, we'll check, because I am very much sure that you are never going to get equal sign. Okay, at any cost a minus b is never going to become a b minus a. Only okay, at any cost, even if you take one number 0 also, let's say, even if you take a as a 0, b as any number, then also you are not going to get the same answer. You try it in your home. Okay, they take it as a challenge. Next one, I will go for multiplication. Third one. So, third point in commutative property of integer, under which operation? Multiplication. So same here. Let us choose any two numbers, a and b. Say this time I will choose one negative, one positive number. Plus 15 minus 10. If I multiply a into b, this is multiplication is operation. A and b are the operands. If I exchange the operands, that is b into a, then I must get the same answer to say what integers are commutative under multiplication. If I get different answer, then these integers are not commutative under multiplication. Let's try. Substitute. Plus 15 into minus 10. First open the brackets, plus into plus, plus 15, plus into minus, minus 10. So in last we learned, while multiplying any two numbers, first we need to multiply their sign. Plus into minus, minus 15 into 10, 150. So our answer is minus 150. Now substitute here. minus 10 in place of b minus 10 into in place of a plus 15. Okay, now open the bracket, plus into minus minus 10 into plus plus 15 minus into plus minus 10 into 15 is 150. So minus 150 minus 1, yes, they are equal. Therefore a into b is equals to b into a. Therefore what is our conclusion? Integers are commutative under multiplication. Okay, therefore integers are commutative under multiplication. Okay. You can write this much in your notes. One example is sufficient. Sufficient. No need to worry about how much examples I have tried. If you understand what is commutative property, then it's well enough. Okay. Now fourth one, I will solve half and I will give that is division. Okay. In case of division, what happens as a homework for you, I will leave that part writing this last final conclusion for you only. Okay. I will try. Last one is a division. So look, same again, choose any two operands a and b. If a divided by b, that is a by b is equals to b by a, then what you can say? Integers are commutative under division. If your answer differs, it's not. Okay, division, let's see. A say plus 4 or just 4, both are positive only, 4 and 2. Here I have to check a by b, here I have to check b by a divided by b. I changed the operands. I send the b which is in denominator to numerator and a is in numerator to denominator. I changed the operands and the result must not change, should not change. Then only we can say it's a commutative under division. If it differs, then it's not. Substitute the values. In place of a, 4. In place of b, 2. 4 divided by 2, you can cancel 2 ones are 2, 2 twos are 4. So your answer is 2 by 1. Here, in place of b, 2. In place of b, 2. In place of a, 4. 2 ones are 2, 2 twos are 4. So your answer is 1 by 2. Now you tell me whether 2 by 1 is equals to 1 by 2. I don't know. You just write your conclusion. How I wrote my conclusion for above 3 in previous 3 sub properties, that is commutative property under addition, subtraction and multiplication. Likewise, you have to write the conclusion for this last fourth one division. Okay, this is take it as a homework. I hope you understood the commutative property. We will see tomorrow. I will see you with a new property, that is associative property. Thank you one and all. Have a nice day.